Okay, in this video we're going to talk about the difference quotient. And it's another way to take a derivative. It's a little bit more complicated, so you're going to have to be very precise in how you do this. So I've written down some things here, and I'm saying finding the first derivative, so still finding the first derivative of a function using the difference quotient. Here's your function. Now you already know using the power rule that that derivative will be 2x. If you can figure it out using the power rule before you start the difference quotient, I would highly recommend that, because then you know where you're going. So remember, this is your difference quotient. You're taking the limit as h goes to 0 of y2 minus y1 over x2 minus x1. This is just a fancier way to write that, but it's the same thing. Okay, on the next page we'll actually start doing that. Okay, so this is how you're going to set up your problem. Given f of x equals x squared, they're going to tell you to find f prime x using the difference quotient. So you can not only use the power rule, you have to do the difference quotient. So here's my function. You're going to take the function plus h. So see how I have x plus h squared minus the function by itself all over x plus h, that's your x2 minus x. Okay, that's your first step. Okay, second step, we're going to expand the first term. So if you take x plus h squared, then you're going to expand that to x squared plus 2xh plus h squared. And then you still have the minus x squared. Alright, now what's going to happen, which is very, very important, is every single term in the numerator that does not have an h attached to it should cancel, because you should have the opposite term. At this point in my denominator, I'm going to cancel the x's. This is what I have next. Rewrite it in this form, and every single time you have to write limit as h goes to 0, limit as h goes to 0, limit as h goes to 0. Okay, your next step is going to be greatest common factor factoring. So all I did was factor out the h from the numerator and the h from the denominator. Alright, those h's will cancel. Remember, I still have the limit as h goes to 0 right here. Alright, once you do not have an h in the denominator, so once this guy canceled right here, you may now actually take the limit. You were just practicing and expanding it until you can take the limit. When you take the limit, what you're actually doing is saying that the limit as h goes to 0, when I actually plug in the 0, I get 2x. 2x is your first derivative, and that's what we thought we would get, and this is how you get it using the difference quotient. So think about that. We're going to practice doing it with lots of different functions, and you will get very good at this. This is all algebra skills, so you have to be systematic, write neatly, keep your steps vertically aligned, and write limit as h goes to 0 every time until you actually take the limit. Once you take the limit, you are allowed to just say in the final step, f prime of x equals 2x. So one little background thing. What exactly are we doing when we're doing this difference quotient? What you're doing is this. You are taking your parabola, and that's a very poor looking parabola, and I had the following. I have a point here, I have a point here. Alright, this is x, this is x plus h. And I'll do this better in class, but without a ruler and just doing it the way I'm doing it. You initially have the slope of a secant line, where it hits the curve in two places. As x plus h approaches x, and when does it do that? It does that when h is 0. You are then approaching a tangent line. So when you get the slope of a tangent line, you then have the slope of the function at that point, and we're here. So that's a little background in a very quick and dirty sketch, but we'll talk more about this in class.